share the instruction with you next week. Yeah, so I hope you already formed the group. Okay, you can form on your own. Okay, 5 students per group. Okay, please make sure not more than 5. We have 60 students. Okay, so we should have 12 group. Okay, 12 group, 5 for each group. You can mix between section 1 and 2. There is no restriction. You can mix between section 1 and 2. Okay, and then okay, so I will share with you the instruction next week, and just make sure you form the group this week before you start the group assignment. Any student who don't have partners or group, okay, because every semester there will be 1 or 2, 3 or 4, 5 students, okay, who not belong to any groups. Just let me know so that maybe 4 or 5 of you can form another group.
I don't have group member, doctor.
Alison, you don't have group member, okay?
Yes, doctor.
Okay, you just wait, Alison, okay?
Alright, doctor.
Maybe you can raise this in our group, in
Alright,
WhatsApp
okay,
group,
doctor.
okay? You can ask anyone who don't have group. If you, let's say, if you don't have group, that means there will be a group that only have 4 members, right? So you can join them.
Okay, doctor.
Okay,
Thank
we
you,
sort this
doctor.
later. Just make sure all of you try to form the group first, and then anyone who left out, so we will sort that later. Okay, thanks, Alison. Okay, continue with the lecture. So we need to finish this because the maybe just maybe it will be in test 2. So we need to make sure to complete this. Okay, last week we have covered pipe network. Okay, easy. Like I've told you before, this subchapters or this chapter is the easiest chapter in finite element method. Okay, fluid and axial chapter. If you can do axial element, you can score axial element. There's no reason you cannot score this. Okay. The next one, fluid mechanics problem. The problem here is the fluid flow between parallel plates, or fluid flow between parallel channel. Okay, let's say we have this fluid flowing between 2 plates. We have the top and bottom plate here. The fluid flowing from left to the right. We are interested to find what is the velocity. Also, what are the velocities of the point across this channel. Okay, the point that we are interested to find the velocities represented by this yellow dot, or what we call node. If an element we call node, the yellow dot here. Let's say we want to find what is the velocity in the middle. What is the velocity here, or here at the bottom here? Okay. The parameters that we need to find this is the dynamic viscosity of the fluid. mu, what we call mu. We need to know the pressure drop, inflow direction, what we call dp dx. Okay, and then we need to know the length, okay, the distance between two parallel plates, the top and the bottom plate, the distance, and that's what we call L. Okay, L is the height, height. And then we need to know the width. Sorry, no, not the width, sorry. The length, sorry. We need to know the length. Okay, width will come later on. What I mean, we need to know the length here. It's not the value. It's not the length. Let's say that we need to know it is 1 meter or 10 meter. We need to know the length is very or relatively long as compared to the height. That's the condition to use this formula here, to use this method. Okay, the length of the channel should be relatively long as compared to the height, okay, of this channel here. The distance between the two plates. Okay, why the reason? Why is it we need to be long, long enough so that it have time and to develop laminar flow. Okay, so that we can get the steady flow, the laminar flow. And that's the assumption, and the condition. We don't need to know the length, we don't need to know the value for the length, because here, this L here is not length. The formula we have K equals to mu over L. L here is not this length here, it's not distance from left to right. It is the distance from bottom to the top, or top to the bottom. L here actually is the height. It's not the length, it's the height. This one here, height. Width here, okay, is the measurement in x-axis. Sorry, in z-axis. Width here. For if the height is in y-axis, length x-axis, this width here z-axis. Come out from the screen. Width. This is view of the cross section of this channel. The cross section view of the channel. Height, width and length. This is not long, actually this is length, L-E-N-G-T-H, length. Okay, so to calculate the velocity, we need to form this equation. Ku equals to F. Look familiar? Similar to axial problem. We need to calculate K. K is the for axial problem is the stiffness matrix. Okay, for this one here is not stiffness matrix. I think I don't remember the name. I think it's the flow resistivity. I think. K here is the flow resistivity matrix, which is mu over L multiplied by 1 minus 1 minus 1 1. So this looks familiar. For axial problem, we have AE over L. AE over L. Now we have mu over L. Okay, so this is the easy part. And then the difference between the axial problem and with this fluid mechanics problem, we have formula for F. We need to calculate F by using the pressure drop. Minus, don't forget to put minus here, minus dP over dx multiplied by L, which is the height. Okay, L is the height, it's not the length, it's the height, divided by 2. And then multiply by 1. And that's formula for this load, for the load, fluid loading. Okay, we try to solve this. So we look at this problem here. We have fluid flowing between the parallel channel. Okay. Given here, it says that the element is distributed evenly. That means the distance from node 1 to node 2, okay, similar to node 2 to 3, 3 to 4, 4 to 5, and so on. We have 6 elements here. Element 1, 2, 3, 4, 5, 6 element. Okay, pressure drop dP dx 120 Pascal per meter. Okay, pressure drop means pressure here, pressure at this point here minus pressure at this point here. Okay, and then we have temperature. Okay, this is might be confusing. Okay, go back here. In the formula, there's no temperature here. No temperature in the formula. Actually, you don't need to use the value for the temperature in the calculation. This temperature here only to show that the top part is hotter than the bottom part. Okay, the bottom plate here, the bottom plate 20 degrees Celsius, the top plate 50 degrees Celsius. So since it has a temperature difference between these two, it will result in the variation in the viscosity. Okay, where mu1 here is the viscosity for fluid at element 1 here. Okay, mu2 viscosity for element 2. Okay, and so on up to mu6 viscosity for fluid at element 6 here. Okay, as you can see here, the viscosity decreasing. Okay, this is high viscosity here, and then low viscosity here, it's decreasing. Okay, from bottom to the top because of the temperature here. Colder temperature, hotter temperature. Okay, this is the reason why information about temperature given here, just to show due to the temperature difference, okay, we will get variation in viscosity. Viscosity is the value that we need to key in the formula for every element. And then what else here we can see here, the length is given here 3 meter. Okay, the height 9 cm, 9 centimeter. Okay, if you compare 9 centimeter to 3 meter, which is okay, 3 meter is very long, relatively very long as compared to 9 cm. So that means laminar flow or steady flow already developed in this channel, so we can use this formula We cannot use this for turbulent flow. It's only for laminar flow. Okay, and then width given here as well. That's to show that the width here also shorter, or the length here is relatively very long as compared to the width. Okay, for TCM. Okay. Now we try to solve this. Okay, we will Excel. I'll use Excel. Okay, we put title, class example, fluid mechanics, problem. Okay, bigger. Okay, next we copy this question. Okay, next table. Remember to draw this table here. Don't forget, or don't try any other way to do it. Just draw this table here. Okay, so we should have node I and node J. Okay, now this is the part where we want to find K. We want to calculate K and F. So we go back to the slide here. Okay, so we need to copy this formula here. Okay, new. Okay, put the formula there. Okay, first we need to calculate K. K is this part here. What we need for K is mu and L. Okay, mu and L. And then we can calculate K. K, which is equals to mu over L. Next, we need to calculate F. This part here. First, we need dP over dx. We already have L here. Okay, and then divide by 2. So, calculate F there. Okay, where F equals to minus, don't forget to put minus there. Now we have minus dP over dx maybe it's too long. Multiply by L Okay, and then divide by 2. That's quite long formula. Just write here to show you okay, just to show you how we get this f. Okay, but in your test you don't have to write this. You don't have to write k equals to mu over L. Just put k there. Put k. Similar here, f, you don't have to write dp over minus dp dx. Just put f. Okay, element, we have 6 element. Element 1, 2, 3, 4, 5, 6. Well, oops. Okay, notes given here. Okay, notes nicely written there. 1, 2, 2. Okay, we start from the bottom to the top. Okay, why? We start from the bottom. Actually, you can start from top to the bottom, but in this case, it is better to start from bottom to the top because mu given here, mu1, okay, mu1 is actually for this element here, mu1 here, with the highest viscosity, 0.775. Okay, if you uh, did not notice this, maybe you will make mistake. You put mu1 for this one here. So since this is the node already given to you, maybe in the question in test, it will not give it is not given to you. You don't know which one is node 1, which one is node 7. Maybe you will start one here, 1, 2, 3, 4, 5. So 1 to 2 means mu1. So that you will make mistake that you put mu1 at the top here. Actually here mu1 here is to the bottom because it is more viscous. Okay, because it is colder at the bottom here. Just make sure you know the reason why we start at the bottom here. Because mu1 correspond to the bottom element here. Okay, so node 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Okay, now, okay, here mu for element 1, mu1 0.775. Just copy this value here. Mu2 0.525. Mu3 0.34, 024, 016, and then finally 011. Next, L. L, the question tell us that the element is distributed evenly. That means the distance between node 1 to node 2, node 2 to 3 is all the same. From the question, the height 9 cm. Okay, the distance from the bottom to the top is 9 centimeter. So we have 6 elements. That means equals to 9 centimeter. We need to convert. Don't forget to convert to meter. It is in centimeter. We need to convert to meter because viscosity here is in meter, kg per meter second. If you notice that. So later on we will calculate K, which is mu over L. So we need to, the unit need to be consistent, meter and meter. You cannot divide centimeter with meter. Okay, so convert first. 9e minus 2 centimeter convert to meter. Okay, and then divide by 6. 9 centimeter divided by 6 element. Okay, and then we get the distance for all the elements. Same value, 0.015 unit meter. Okay, I put unit there, so we aware that the unit is in meter. Now we can calculate K, which is equals to mu divided by L. Okay, reduce the decimal number. Just use 3 significant figures, 51.7. That's enough. Next, dpdx. From the question, dpdx is 120. Pressure drop 120, similar to all. Okay, next, use the formula here, this force formula. Minus dpdx, don't forget to put minus. Usually, students tends to make careless mistake here. He or she forgot to put minus sign there. So you will get wrong answer. If you forget to put minus, if let's say the answer should be in positive, you get in negative. The answer should be in negative, you get in positive. Okay, minus dpdx. That dpdx there, multiply by L divided by 2.
Doktor,
Yeah,
pressure drop tu bukan negatif ke?
pressure drop tu, sorry, say again.
Bukan negatif ke?
120. Positive value there.
Positif.
So what is bagus soalan, good question there. If the pressure drop is positive, that means what is it? What it mean? It means that pressure here is higher than here, right? Pressure at the right higher than the left side, because pressure drop here, how do we calculate this? Is actually pressure at the right minus pressure at the left here. Since it is positive, that means flow is from right to the left. You should get velocity. Later on, you should get velocity in negative value. That means flow from right to the left. It's not from left to the right. At this moment, we assume because from this from here, from this note here, lecture slide here, we assume from left to the right, but actually it depends on the pressure drop value. If it is positive, actually it is from right to the left. Clear? But we still call it pressure drop. Okay. Okay, next. Okay. Now we can create the stiffness for each of the element. We need to calculate U, the velocity. So we will have, okay, number of global matrix. 7 nodes. 1, 2, 3, 4, 7. Degree of freedom, only one, which is velocity, horizontal velocity. In this case, we try to find mu, u in horizontal, in x direction. So 1, 7 times 1, 1. So we should have u1, u2, u3, 4, u5, u6, and then u7. 3, 4, 5, 6, 7. Transpose. This one is for K1. Okay, we have 6K. Just copy paste. K2, K3, K4, K5, K6, and then total K here. One, two, three, four, 5, 6. Okay, this is the easy part. I just put yellow there to show that, okay, for element 1, K1, node I and J is 1, 2. Okay, element 2, 2, 3. Okay, 3, 3, 4. Here, 4, 5. 5, 6. And then 6, 7. Okay, in Excel, this is the, okay, the tips I want to share with you. In Excel, okay, you have to do this. You have to do this. So you need to do in global, and then because you need to edit in global. Okay, but in test, you just write this part here. You just write this part, that u1, u2. Only copy this part. You in Excel, you need to do it global, but this is local, right? This is global. Maybe I need to write here. This is global matrix. This is local matrix. Similarly here, for K2, you just write K2. But make sure this is U2, U3. Okay, if you write this in your answer, and you submit to me, I can accept this. Okay, because I know you understand that, okay, what is the position of the value here. Because you put label here, U2, U3, and U2, U3 here. I can accept this. You don't have to write all this. So you can save lots of time. Just make sure you put the right label here, U2, U3. But if you put K2, but you put U1, U2, you still get wrong answer, because from your answer, I cannot judge whether you understand it or not. Okay, whether you know that for K2, the value here correspond for U2 and U3. Similarly, for K3 here, you should put, for K3, you should put U3, U4, U3, U4. Just copy this part here, okay, in your answer, and then send it to me. And you don't have to write all this. I hope that's clear. So we delete this. Okay, now we put value here. Okay, don't make mistake. Here is K, which is mu over L. It's not F. Don't put F. This part here, mu over L. 51.7 multiplied by 1, multiplied by minus 1 there. Minus 1 and 1 here. Here is 35. Oops. Okay, K3, 22.7. K4, 16. Okay, K5, 10.7. Then finally K6, 7.3. Okay, and then total K goes to K1 plus K2, okay, plus K3 plus K4, K5, oops, terlajak. Oh, tersilap pula tadi. Okay, sorry. Okay. One more time. Equals to, okay, equals to K1 plus K2, K3, K4, we tak nak. Okay, Okay, 5. Okay. 1, 2, 3, 4, 5, 6. Control Shift Enter. Okay. So kita dapat totalnya. We get the total. Just the number here, you just write the number. Copy this. Don't copy 0. Don't copy 0. Only copy the numbers. Okay, and use 3 significant figures only, or 1 decimal places, something like that. Okay. Okay. Next we have load. This is quite different to other problem. So we need to prepare the pos or load vector as well. Okay, so we need to prepare here F1 okay, here put color. Later on. So we copy first. F2, F3, F4, F5, 6 total. Okay, put yellow, highlight yellow there. Okay, this is for 1 and 2, 2, 3, 3, 4, 4, 5, 5, 6, and 6, 7. So the value equals to, using the formula here, minus dp dx multiplied by l divided by 2, the one that we have calculated before, here, multiplied by 1, 1. So multiply by 1 here, okay, and another one there. Okay, so actually the value here all same, 0.9, all are the same. You can just copy and then paste value there. And then find the total, which is equals to F1 plus F2 plus F3, and then so on. F1 plus F2 plus F3 plus F4, 5, and then apa dekat sini je, something wrong there. Okay, Control Shift Enter. Baik. Maybe I edit twice. Wait. To check this. M69. Twice. Okay. Check. Oh. Just undo equals to okay. Okay. Oh, ini pun twice ya. C69, I75. Okay, ni pun tak bagi juga. Okay. So, we need to do it again. Delete. Lepas tu, I don't know why, what's the problem there. Dia tak keluar colour. Last. Add. Okay, 5 here, no colour. Don't know why. Okay, 6. Okay. Total okay, so now the matrix equation. Okay, matrix equation. K. Okay, Ku equals to F. K times U, this is U, the velocity. Remember, U here is velocity, not displacement. Okay, that we try to find here. Apa dah pula ni? Okay, F. Okay, K times U equals to F. Next. Okay. Constraint by penalty method. Yes. Let's say we use penalty method. Copy this. Okay, for penalty method, C, very big number, 1 E30. Okay, the constraint here in fleet mechanics. In our case, we assume node 1 or the fluid, okay, at the surface of the bottom and the top plate here equals to 0. That means U1 equals to 0, U7 equals to 0 as well. That's the constraint. So U1 equals to U7 equals to 0. These two are the constraints. U1 and U7 equals to 0. So we put U1 here plus C, U1 plus C here, okay, plus C multiplied by 0. Here U7 plus C here plus C multiply by 0. Okay, next inverse. Okay, inverse K. Equals to N inverse and then velocity. Equals to matrix multiplication inverse K multiplied by F. Okay, too big number. Okay, so reduce. Okay, so that's our answer. So unit is meter per second. Velocity meter per second. Okay, so if you notice, we have negative value. That means from right to the left. Okay, flow from right to the left. Okay, the value here very small. These two value very small. This is approximately equals to 0. Okay, E to the power of minus 30. So maybe we can try change to number. Okay, so so we get this answer here. Okay, any question? Determine the velocity in every node. So we get the velocity, and we get the velocity every node from node 1 to node 2 and node 6. Node 1 and 7 0, and then draw the profile. So we need to draw the profile, so you can just sketch manually the profile, or you can, in this case, we can use Excel here. Okay, try to use to remember how to do it. And I try to remember how to do it. Profile. I think this one here. Select data. Horizontal. Select data source. Yeah, I think that's more like it. And then put trend line. Only okay, that's the profile. And then you can play around, you can adjust this. Okay, before I do it. Okay, thinner. Okay, that's the profile. Flow from right to the left. Okay, note, this is note 1, 2, 3, 4, 5, 6, 7, and then this is the value for velocity. Okay, 0, minus 0 0.1, 0 0.2. Okay, any question? Ada soalan? Okay, easy I think this one easy. Okay, the K matrix, very simple. You just use the formula, and then you get K1 up to K6, and then find the total, and then you need to find load using the formula here, F. Okay, F1, F2, F3 up to F6, and then find the total, form the matrix equation, apply the constraint. Here I use penalty method, and then inverse the K, and then you multiply F, you get the nodal velocity. Okay, and then from there, you can sketch the velocity profile manually or in test. Of course, you should sketch manually. But if you're not sure how it will look like, and you can just use Excel and then just copy the flow, the vector, the velocity profile, okay, from the Excel. You make sure if symbol here negative. Okay, if the dp dx here positive, that means flow from right to the left, you should get negative value. But if the dp dx equals to negative, dp dx, let's say minus 120, okay, and then flow from left to the right. Okay, that's actually it's easy to change that. If we put negative here, let's say I put negative 120 there. Okay, so change 0.9, automatically 0.9 become positive, and then the, oops, what's wrong? Oh, because I use negative there. Actually, I should copy. Paste link. Okay, paste link. Okay, and then from right to the left. Okay, for negative value of negative 120. So change back to positive. So change back to from right to the left. Okay, any question? The last example, fluid mechanics. Okay, ada soalan? 11 suku, baru 11 suku hari ni. Habis quite early. We finish the example today.
No question.
No question.
Kena buat balik baru boleh faham.
Yeah, try to do it on your own.
Doktor,
Yeah.
L ambil daripada long lah.
L height. Tu jangan confuse. Like I said, L here, this L here is not length, it's not long, it's height. This height here. Don't get confused. This value here, long here, it's not long lah, length. It's length here. 3 meter is just to show that untuk tunjukkan yang panjang ini sangat panjang dibandingkan dengan height. Itu je maksud dia. Supaya dia dapat develop laminar flow. Okay, 9 cm compared to 3 meter, okay, very small lah. So akan develop laminar flow. That's only the reason. You don't need the value here, 3 meter. You don't have to use this value. Actually, if you kalau tak tahu pun, you don't know the value, you can solve this. It's enough. The question tell you that the length of the channel is very long relative to the height. Then that's it. Okay. And then width here, what? Actually width, width, width here 40 cm. Okay, let's say from here, the question asks us to find what is the flow rate. What is the flow rate in the channel? Now you need this width here. So velocity multiplied by the width, right? So you will get the flow rate. Velocity multiplied by width and height. So because velocity multiplied by the area, you get volume flow rate. Multiplied by 9 cm convert to meter, 40 cm convert to meter, you get the area, cross-section area. Right? From the cross-section area, multiply with the velocity value here, multiply with the velocity, so we get flow rate Q.
Faham.
Here, I mean flow rate for every element. So for total flow rate, you need to find the total. So you multiply area for every element. For every element, you calculate the area, cross-section area, multiply with the velocity, and then total, tambah hasil semuanya, you get total flow rate. Because the flow rate here different to here and different to here. This part here have more flow rate as compared to this part. Okay. So scan attendance.